So this is our first tutorial about using Git and GitHub. And your first question might be, what does this have to do with machine learning? Well, if you're doing machine learning, then you're using some code. So you're either using your own code or you're using someone else's code or a combination of the two. So the first thing you can do with Git is it lets you manage your own code development or code development in a team. So here we've got a graph in GitHub showing the code development that's been conducted by my research group right now. And each one of these, what we call branches, represents essentially a different stream of work. Each one of these blobs represents a change to the code. So people are conducting these different streams of work, and then we can combine them and merge them, etc. As appropriate. And we'll learn how to do that later. It also lets you contribute to large open source projects. So this is the GitHub page for Scikit Learn, which I think is probably the largest repository of machine learning code in Python. And so what we have here is all the code essentially. And then on this tab we have issues. So this is where people can raise bugs that they found or just problems that they have or suggest new features. And then this tab has something called pull requests, which is where people can contribute code to the code base. So here they might contribute code that resolves bugs, resolves issues that have already been raised, or just completely new features. And I try and do this sometimes, and it's good fun, and it's a good way to contribute to a project that's used by loads and loads of people. So I think it's a good thing to do. Also, more and more these days, we release code with academic papers, or we should do. So this is one of our GitHub repositories that accompanies a paper that's down here, catchy title, classic academic title. So that's the paper. Here are some instructions about how to use the code. The code itself is here. So from this repository, you can run code that will replicate any of the results that are in the paper. And it's a good way to kind of improve the transparency of academic work. And then as a last example, this is a website called Papers with Code. So here people have taken papers and then they've written code that replicates the results in those papers, and they've released that code for free. So here are papers, here are links to code, and all the code is maintained in GitHub. So through Git and GitHub, it's a really good way to manage your own coding projects, manage projects with other teams or open source projects, as well as get access to code that's published alongside academic papers. So it really unlocks a huge amount of kind of resources that you can use. So it's good. Right, so the first thing to do obviously is to download and install Git. Usually I wouldn't bother talking you through this, but there is something that's worth noting. So when you go to install Git, blah, 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 you get some options. It gives you the option of using a default editor. Okay, so what this means is that sometimes the program Git wants to get you to enter some text. And so it will load whatever default text editor you've got to get you to do that. If you don't specify a text editor, then it will automatically open Vim, a text editor called Vim, which some people love, but if you're kind of new to this stuff, it's an absolute nightmare and you can get trapped in it forever. It's actually quite hard to even close it when it opens if you don't know how. So before you install Git, my advice is to install a good text editor. If you're not sure what to do, I use something called Notepad++, which is free, and that's fine for getting you started. Okay, so that'll do for now. So before you install Git, I'd advise you to install Notepad++, and then when it asks you at this point to choose a default editor, then you can just choose it here. Use Notepad++, and just do that as part of the installation. And yeah, it should make life a lot easier later. So I'm going to assume now that you've installed Git and that you've got an account on GitHub. So now what we're going to do is we're going to go into GitHub and create a repository. So that's an online place where our code's going to be stored. So I'll open up, this is my GitHub account, and I'm going to zoom in over here, and we're going to create a new repository. And we're just going to call it test. Very original. We can give it a description if we like. We can make it public so anyone can see it, or we can keep it private. And there's a load of other options like adding a README file, a license, etc., which we're not going to bother with for now. So I'm going to create the repository. And there we have it. We have a place online where we can kind of send our code as we update it. So now the next step is to get a kind of copy of that repository on our computer. So I'm going to go onto the desktop and right click, and if you've installed Git, then you'll have these two options here. So there's the Git graphical user interface. So there's lots of different GUIs for Git. But I've never really got on with any of them, to be honest. And the most useful way that I found to use Git is just by basically typing in commands. So that's what I'll do here. So if you click on Git bash, it brings up this window where you can type in commands for Git. So we'll just zoom in a bit. So like I said, we're going to take that online repository and we're going to create a copy of it on our computer. So the first thing to do is to copy the web address, and I'm going to go to Git, and we're going to use our first Git command, which is Git Clone, and then give it the web address and enter. Okay, so there it is, the folder test. So that is a copy of the online repository. It's told us that there's no code in it, so it's an empty repository, which is absolutely right. So we go in here, and there's nothing in here except for this kind of hidden .git folder, which dictates how this repository interacts with the online repository, essentially. But right now we've got an offline clone of the online repository, and this is something that we can work on offline. So the first thing we're going to need to do is add some files to it. So I'm going to start by adding a text file. I'm going to pretend it's some code basically. So I'll just call this file1, and I'll open it. This is in Notepad++, like I said before, but it'll open in whatever text editor you've got. And we'll pretend to write some code. So we'll put first line of code, just zoom in a bit so it's clear. So we've entered some stuff. I've left a blank line at the end. So yeah, there's some code, that's fine. And then let's say, so what we're going to do is basically we're going to take what's called Git Commit. And you can think of those as just kind of copies of the status of this folder at a particular time. And then we're going to put those commits online. So one of the things you've got to do is you've got to tell Git which files it's going to include in that copy. So I'm also going to include something that perhaps we don't want to share. So I'm going to make another thing called rubbish, another text file, and fill it with rubbish. Okay, so let's just say that's just something that we've used to, to get somewhere with a project or whatever, but we don't necessarily want to share it with anyone else. So if I open Git again, so like I say, we're going to make this copy, but first of all we have to tell Git which files to include in the copy. The first command, well, not the first, the command I'm going to show you now is really, really useful. It's just git status. Just tells you what's going on really. So, okay, we've got two files, file1 and rubbish, and it says it's not tracking either of them. So tracking means it'll include them in copies of this folder. And the thing is, if you go on to keep different copies, like different sets of copies, then you can look at how each file has changed between subsequent kind of iterations of the project, but we'll get to that later. So first thing we need to do is we're going to tell it that we want to track file 1. We want to include that in our first copy, but not rubbish. So we do that with git add, and then in this case we'll just put the file name, so file1.text. Okay, so I'll do git status again, and okay, it says there's changes to be committed. So commit is the Git word for copy, okay, that this copy of the folder. So every time we make one of these copies, there's also a message attached to it. So the idea is, as you look at subsequent copies, the message will tell you roughly what's changed between the different kind of iterations of the project. So we're going to say git commit. So this is going to make our copy for us. We're going to attach what we call a flag -m, and that means that's shorthand basically for message, and then 2 inverted commas. So we're going to put a message in here. This is the message that's going to be attached to this kind of copy of our files. So we'll just say, I don't know, first commit of file 1. Okay, fine. So now at this point, we've got a copy of our folder, including file 1, but not including rubbish. And it's just local. It's just on our computer, so this could all be done totally offline. And the final thing you need to do if you want to get it onto GitHub is you need to type in git push. Okay. So that should put that first copy of the folder onto the test repository in GitHub. So if we open this up and we refresh it, there we go. File 1's appeared, and that message has appeared next to it as well. So we've now put our first file onto GitHub. Right, so now let's say that we want to change this file a bit. So we're going to go back to file 1, and I'm going to say, actually, I'm going to change this first line of code. So we have a different first line of code, and we're also going to have let's say a new kind of second line of code. Okay, fine. So now we've made our changes, and we go back to Git, and we do git status, and it says, okay, we're still not tracking rubbish. That's fine. We're fine with that. But file1.text has been modified. If you've forgotten what you've done, one useful thing to do is you can say, okay, well, what's git diff file1.text if you've forgotten what you've changed, which happens quite a lot to me anyway. It says, oh, okay, this first line of code has disappeared basically, and it's been replaced by this line of code, and we've also got this line of code as well. Okay, fine. So we've got, we can now try and get this modified file1.text onto GitHub, and then we basically just need to follow exactly the same procedure. So at this point we could say, again, we could just say git add file1.text, then do git commit with a message, and then git push again. One useful thing is to say, well, actually maybe I just want to add all the things that have changed. I don't want to type in every single file one by one if you've changed lots of files. So if you want to do that, you can say, well, git add, and you can add another flag, and that's shorthand for update. So that means all the files that have been updated. So if we do git status again, it says, okay, yeah, it's just that one in this case. So a new commit, so git commit, another message. So, okay, I made changes to file 1. So obviously if you're working with other people, or even if you're just working on your own, it's quite important to keep these messages meaningful rather than, you know, small change, whatever. And then we'll do another git push. Okay, go back to GitHub. And yeah, you can see it's changed, made changes to file 1. Okay, so now we can actually just click on this and have a look at this. This will now tell you what's changed in this commit compared to the previous commit. So it's telling us in this case that the first line of code, remember that was deleted and it's been replaced by these. So that first line of file1.txt is now being replaced with this. And the second line now has this second line of code as well. And there's various different ways you can see how the files have changed. So I've got them kind of split side by side here. I think you can also show it like this, etc., etc. So one of the things GitHub does is it's showing how the bit of your code that's hosted online has changed over various different commits. You can also do things like, something that's quite useful is if you go into Insights and then Network, it will show you kind of a graphical representation of what's happened. So each one of these dots is a commit. So each is like a copy of the files in the folder. So the first one says, first commit of file 1. And the second one says made changes to file 1. And again, you can click on any of those and it will show you what's changed. Okay, I think that'll do. So in the next video, I'll go back to this network thing. We'll look at branching and merging. So branching basically means you can generate a new kind of stream of work off one of these commits. Then you can merge them with other streams of work, etc., etc. So we'll do that in the next one.